Yeah, a little update. Sun's coming out, and I've got positive going charge to my boost capacitor at the moment, my super capacitor at the moment. It's yeah, the sun's just come up and it's been stuck at about 6 volts. So it was I think it was about 6.5 volts a few minutes ago, and it's actually started to drop very slowly, but the voltage wasn't high enough. Voltage wasn't high enough to trigger the relay, because the relay needs at least about 10 volts really to trip the relay. Anyway, it's positively going again because of the sun coming out, and it's starting to climb. Hopefully it'll get to about 10 volts or something, and then when the sun goes back, when the sun starts to go off again, then it should trip and send that power to the battery. So yeah, we're at about 27 triggers so far in total, because it's been remembering, and that's my old timer thing I made years ago. It doesn't actually flicker this because it doesn't use a scan method, so I had to put it on a very 1.5k resistor, the whole board, just so it wouldn't use much power, because it tends to be kind of greedy. But so there's not much light. Hang on. Yeah, so that's better. Yeah, this is something I made in college, way back, I think in the 80s, and it's kind of old, but it works. It's just a 2-digit counter. So, and my circuit, I'm actually doing the circuit diagram at the moment. I'm currently doing the circuit design on the PCB design software, and as soon as I get that done, I'm using generic values for the resistors at the moment, but as soon as I get the circuit board design done, then I can actually get the the values of the resistors off this breadboard and put them onto the circuit diagram. But I'm going to do that later, because I'm still tweaking it a bit, you know. But yeah, it's getting close to 9 volts. Very close now. The sun seems to be, well, it's still shining. I can see the sun coming through the window here. This is the sun coming through the gap. So yeah, we're at 9 volts now. So if the sun happens to go in now, there's a high probability that the circuit will trip. Yeah, I'm kind of happy with this. It's working quite well. I got some PCB, single-sided copper board. It's only a small piece. It's 100mm by 150, but I'm going to have to cut this anyway. It's a bit bigger than what I want for this circuit, so I'm probably going to cut it into a third. About a third. The size should be big enough. It's fiberglass. Actually, I wanted the Paxilin one. I didn't realise it was flipping. Yeah, fiberglass is stronger but harder to cut. I was trying to pause it then. Yeah, we're 9.12, 9.30. It's going up fast now. Just entirely solar power right now, and it's coming up fast actually. I'm just going to wait for the sun to go down, and then I'll try and record it tripping over. Well, it looks like the sun is actually, yeah, it's dimming. So it's probably going to trip any second. If it goes into a static or negative charge, then that circuit will flash the LED and it'll probably dump that energy. But it does seem to be still climbing, so actually I'll put my meter on. My meter just says we're at minus 0.09, so it won't trip until it goes to a positive or to 0, 0, so we've got quite a way to go yet. And actually, just by looking at the meter, I can tell, just by looking at the offsets, you know, the positive, the inverting and non-inverting voltage, I can tell just from this value here that when it's going to trip, and it's not going to trip by the looks of it, because it looks like the sun's coming out again. Well, it's going more negative anyway. If it keeps going negative, it's not going to trip. So that's good. Working quite well actually. I did put some Zener diodes in the circuit. I put a 3-volt Zener diode in series with the output from, well, it's in between a resistor and to the LED, and also to the 555 timer pin 2. And the 3-volt Zener actually prevents the circuit from tripping when the voltage drops to a certain point to about 6 volts. It gives me enough of a voltage drop that it won't try to trip the relay at a voltage that it can't trip, you know what I mean? Because the relay needs at least 10 volts really to trigger it, you know, to pull it on. Because the relay tends to release around 5 volts, so there's no chance of it being the relay activating at 6 volts. It needs about 10 at least, because it's a 12 volt relay, you know. So about 10 volts it will trip over, but no chance at 6. So yeah, for the LED light. Oh well, just wasting video. You've seen it trip before, so it's not worth the point. I just wanted to do a little update, that's all. This is just an approximation of my circuit diagram so far. The current comes in to my circuit. The resistor values are not right. Well, this is right, this one, but that's where the current comes in. And I've got my sense diode resistors for the inverting and non-inverting going down, and then there's the hot preset, which is one of them connected to ground down here, and then I've got a transistor here which basically pulls down see where are we, pulls down pin 3, the non-inverting. I think I got that right. I'm still doing the diagram though. But it basically pulls down the non-inverting during times when it's been activated, so that it doesn't get stuck basically, and it kind of cycles, and then goes through like a what do you call it? I think you call it a pi tank or something, or anyway, there's a capacitor there, and there's a resistor on each side, and it goes to the base of the transistor. The transistor is not the right value. I'm just using a generic transistor. Well, it's a BC109C actually, and like a pi tank, the capacitor basically charges up slowly during the time when it's been activated, because that resistor, those values are not right yet. They're all wrong values, so you can't use those. But I've got us in a diode there, which no, that's an LED. Sorry. And that's driven by a resistor, and yeah, well, it's a pi tank, and that goes on to PMP collector. Well, the voltage comes out of the collector, and that transistor is basically turned on through a resistor. Well, that's not the right value yet, but it's a resistor in series with a diode, because it's, don't forget, that's a PMP, so the voltage is actually pulled through there by another transistor. Well, sorry, not transistor, a little FET. The FET is turned on. I'm not sure if I've got the drain and source the right way around actually. I'll have to check that later. But yeah, and that's to pin 3, the output of the op amp, and got the voltage for the op amp goes through a resistor and to a capacitor down here, and there's a diode which keeps the voltage at about 9.1 volts so that the op amp doesn't get too high a voltage. And there's back to the FET, and that's connected. Well, one of them is connected to ground, and the rest of the op amp. There's a capacitor across that. The capacitor, well, it says null there, but it's pin 1 and pin 8. Actually, the conversation on. I couldn't find the right op amp in the schematic design, so I just used the generic one. But it's actually compensate for pin 8 and pin 1. And yeah, well, pretty basic circuit really. And yeah, I just thought I'd share that because ignore that because I just left that there in case I need to copy it. But yeah, I've still got to put the values in, but there's not a lot there really. It's fairly simple circuit, but it works and it does the job. Back to the preset, yeah, that's the ground. Let's see, not a volt. So yeah, going back up here, that's where the voltage across that resistor gives me the differential. So I know there's a load on this end, on that end. Yeah, simple circuit. But that pi tank, basically, that just it actually cycles at a certain threshold when there's no load. It goes into that's what makes the LED flash every so often. It goes into a cyclic type mode. It keeps swinging between minus inverting and positive inverting, and that little tank there with a capacitor and a resistor causes that to happen. That just gives me allows the circuit to swing both ways so it doesn't get stuck in one mode, because the tank gives it a sense. It moves the sensing back into a negative, so that if a load comes on here, it's going to be swinging backwards and forwards like a swing, this tank. So it kind of overcomes that problem where it would get stuck in one mode. So anyway, so that's that.